My project is an Rfid access controller. It's a locking system that works on RFID tags, which are magnetic cards, and they allow access to a certain user at a certain time, depending on, say, a class or different hours of a building. I picked this project because I have personal interest in it. I have this exact unit at work, and I thought it'd be neat to try it out for myself and see if I could do it. The challenges that I've encountered were a few hardware problems, which faulty parts, bad wiring, just human error. A lot of other challenges had to do with the GUI itself and the firmware. There's a big challenge in programming it the right way to make everything work together and to interface between both firmware and software. I would recommend that they pay a lot of attention to what they do, and also make sure they have enough time, as in if they set a date, double the work, double the amount of work that you would have to put into it, because it is a very large project and it does take time.
So my project is a scale trainer for guitar, and it'll tell the user what notes to play, and it'll gauge whether or not the notes they're playing are right with a long math algorithm. So I applied basically what we learned in a lot of the different classes, from fast Fourier transforms, which is more the audio side of things, and then the digital, where we actually built a circuit board, sent out, had it built, made, and then we build it up and get it all working and testing and all that. So, challenges I faced were to basically get all the code working together and everything working, because there's all different parts of the system that have to all communicate together. So getting that to work together and managing time is somewhat of a challenge, but it worked. Recommendations for future students, I guess stay on top of everything. As long as you don't sort of fall behind, then everything should be good. You just need to stay focused and stay on top of it, and you can get through everything.
What my project does is it's a remote control tank with a paintball gun on top, so it just drives around and shoots stuff. I chose this project because I'm really interested in the world of paintball, and it's a real hobby of mine. Plus I thought it'd be a cool idea to have my own personal tank. Did I apply what I learned in the last few years? Definitely. From the circuit design to the software, I couldn't have been able to do what I did this year if I didn't take this course, and I'm really happy with the end result. Some of the challenges I encountered with this project was that it deals with high power, so it's really easy to burn things. I burnt probably 10 transistors, so you have to be really careful when touching wires and testing stuff, because stuff can catch on fire with this high current. Recommendations for future students when working on these projects is use your time wisely. I know it's really easy for time to go by fast, and you think you're almost done, but something always comes up and you always end up rushing it at the last second. So definitely use your time wisely.
My project consists of it's a weather station. It consists of 4 different measurements. It measures the wind speed, the direction of the wind's coming from, and it gives you the temperature and relative humidity. Everything through the course, you use it all through your project. For instance, you use how to program a chip, and when you use the everything from C++. I would say always back up everything. Back up your files, back it up. Once you lose it, you go back again. You lose time. So I recommend to do things right away. Don't wait at the end. Don't procrastinate. So you'll end up, you'll find it will go smoothly all the way. But if you wait at the end, then you kind of miss. Then you lose time. If you don't.
Basically what my project does is it's a laser projector. It takes a laser and it bounces off these two mirrors, create an X and Y axis, and with that it can create an image. One reason why I chose this project was basically I was just searching on the internet for anything to do a project on to start off with. And I was looking at YouTube for a while, and I found this really interesting thing about lasers. So I decided to keep on going into it, and I found this website that basically explained everything about it and showed a really neat video about it, and I just knew that's what I wanted to do. It was really cool. The main thing I did with this project was a lot of programming. It was very, very programming intensive. I put a lot of work into creating my graphical user interface, and I spent pretty much weeks, months on that stuff. So it was more programming than anything else. 9% of it was programming. That was mostly what I did. I also did a couple of things with board layout and board design, which I had to modify and tweak as I went along, but it was mostly programming for most of it. What I would recommend to future students is come prepared to every class, basically. Just do the work that needs to be done, and you should have a good time while you're doing it. It's a pretty basic course. You learn a lot of things. It's a lot of hands-on work, but in the end, it's really worth it, and it's great.
My project is a LCD speedometer for a motorcycle, and obviously it displays my current speed, and I also implemented other functions such as trip meters and a clock. And I chose this project because of my interest in motorcycles, and because my motorcycle actually lacks a lot of features, mainly a clock, but also other things like a trip. It only has one trip meter, and this has a lot more. I could put basically as many as I want onto this. So you definitely do use the tools that you're taught to implement your project. In second year, you learn a lot of C programming, and mine's basically all C programming. So state machines and basically menu systems were very important in my project. I would recommend, if you encounter any significant problems, that try to figure it out. But once you reach the point that you don't think the problem can be solved, work on a workaround, because I was able to make a workaround for a problem in about 10 minutes, as opposed to about a month working on the problem.